Welcome to Project Python. This is a series where I, a coding enthusiast, take on several coding challenges to challenge my coding skills and along the way explain my learnings. Each episode focuses on a different problem, and that's about it. So without wasting any time, let's get into this episode of Project Python. Before we start, if you've been enjoying the content, please consider subscribing to the channel and liking the video. Today's challenge is to create a function that can print the Fibonacci sequence up to a specified number of terms. The input will be an integer defining the number of terms we want to print the Fibonacci sequence up to, and the output will be a string of the terms separated by commas. For example, if the function was fed the number 5, then we would expect to see 0, 1, 1, 2, 3 on the output. This is because the first 5 terms of the Fibonacci sequence are 0, 1, 1, 2, and 3, and we want to see these terms separated by a comma at the output. At this point, I would encourage you to pause the video and try solving the problem yourself. Before we start coding, let's try and understand what the Fibonacci sequence is and how it works. The Fibonacci sequence is a series of numbers where each term starting from the third is the sum of the previous 2 terms. Here we can see the first 8 terms of the Fibonacci sequence. If we were to pick any term in this sequence, for example 21, we can see that it is the sum of the 2 terms before it, that is 8 and 13. This is quite simple to understand, but how would you generate such a sequence in Python? To understand that, let's try and generate the sequence ourselves. Let's start with the first 2 terms 0 and 1. We want to find the next term. Let's call this n. We know that n-1, that is the previous term, is 1, and that n-2, the term before that, is 0. To find n, all we have to do is add n-1 and n-2. This gives us 1. Now let's try and find the next term. Again, let's call this term n. We can see that n-1 is now 1 and n-2 is now also 1. Therefore, n would be 2, as it is the sum of n-1 and n-2. Let's stop here and observe what we have done. First of all, we can notice the repetition of a task. Each time we are adding 2 terms to find the next. This hints that in our code, we will be using some sort of a loop. Next, let's take a look at the values of n, n-1 and n-2 and how they changed as we tried to find the terms. Initially, n-1 was 1 and n-2 was 0. This gave us n to be equal to 1. For the next term, we changed the value of n-1 so that it was equal to the previous term. And we also changed the value of n-2 so that it was equal to n-1 for the previous term. This essentially forms the building block for generating the Fibonacci sequence, and we can repeat this process as many times to get as many terms of the Fibonacci sequence. So to generalize this, let's say the number of terms we want to find is x. We start with 2 variables, n-2 and n-1, both set to 0 and 1 respectively. Then we add the 2 variables to find the value of the next term, n. For the next term, we update the values of n-2 and n-1 as follows. We set the value of n-2 to be n-1 for the previous term, and we set the value of n-1 to be equal to that of the previous term. Finally, we repeat steps 2 and 3 x minus 2 number of times. This is because we already have the first 2 terms of the sequence. Therefore, if we repeated this process x number of times, we would have 2 more terms than required. This explains the logic, but in order to execute this, we need to know one more function, the range function. In simple terms, the range function returns a sequence of numbers in a specified range. The syntax of the range function is as follows. Note that the stop term is not included in the range. As an example, if we use the range function where the start term is equal to 0, the step size is equal to 2, and the end term or the stop term is equal to 10, we would have the following sequence of numbers: 0, 2, 4, 6, and 8. Starting from 0, the difference between consecutive terms is 2 due to the step size, and since 10 is not included in the range, we stop at 8. Now that we have all we need, let's begin coding. As always, let's define our function using the def keyword followed by the name of the function. In this case, I will be calling it fib, and this function takes one argument, which is the number of terms of the Fibonacci sequence we want to print, and in this case, I will be calling that x. Next, we're going to define three variables. First, we're going to define n-2 and set this equal to 0. Then we're going to define n-1 and set this equal to 1. Finally, we're going to define a list called terms, and we're going to place inside it 0 and 1 as strings. Since we're starting with the third term, we know that the term before it is 1 and the term before that is 0. Hence the values of n-1 and n-2. The list terms is what we're going to use to store all the terms we find in the process and print at the end of the function. As we saw earlier in the video, in order to calculate a term, we need to add the previous two terms. And we also saw that this was a repetitive task. Therefore, we're now going to use a loop. We're now going to define a for loop that runs x-2 number of times. To do this, we're going to use the range function and only set the stop value as x-2. This means that starting from the default start value, which is 0, this function is going to run x-2 number of times. Remember that the key here is we start counting from 0, not 1. Therefore, even though x-2 is not included, we are still counting x-2 number of times. The first step, as we saw, is to calculate the next term. Let's call this n. We know that n is equal to the sum of the previous two terms, which are n-1 and n-2. So let's set n equal to n-1 plus n-2. Next, we need to update the values of n-2 and n-1. We saw that n-2 needs to be set to n-1 of the previous term. So let's set n-2 equal to n-1. Next, we're going to update the value of n-1 so that it is equal to the previous term. As you can see from our code, we call this term n. So all we have to do is set n-1 equal to n. The last step is to add the term we found to our list of terms. This can be done using the append method. The important thing to note is that we are converting the integer to a string when we store it in our list, so that when we want to print this list, our work becomes easier. When the for loop ends, we will find the first x terms of the Fibonacci sequence stored in our list terms. Now all that's left to do is to return this list as a string with all the terms separated by a comma. To do this, we can use the join method and set the separator to a comma. Now that that's done, all that's left to do is to test our function. So let's throw in a few random values of x and see whether the output we get is correct or not. As you can see, our function works. And this brings us to the end of today's challenge. If you enjoyed the video or found it helpful, please consider subscribing to the channel and liking the video. Please feel free to comment below any alternative solutions you may have found or any questions you may have. And as always, I will see you in the next episode of Project Python.